Hello everyone, welcome to the channel Vidyut Yoga. In this video, we'll discuss about maximum power transfer theorem, study and simulation using virtual laboratory. Before starting the video, those who are new to this channel, please subscribe the channel. So as the title suggests, we'll discuss about maximum power transfer theorem, which we'll explain with the help of the one example and initial discussion. And after that, we'll discuss about demonstration or verification of maximum power transfer theorem by using virtual simulation laboratory. So what is the superposition theorem? So if we go through the statement of superposition theorem, it states that in any linear bilateral network containing two or more sources, the response in any element is equal to the algebraic sum of responses caused by individual sources acting alone, with all other sources non-operative. That is, while considering the effect of individual sources, ideal voltage sources are replaced by short circuit and ideal current sources are replaced by open circuit. So this is the statement of superposition theorem. If we try to understand the meaning of this statement in simple word, in superposition theorem, whenever there are two or more than two sources, what is the meaning of source? It may be the voltage source or current source. So for example, if there are two voltage sources, two or more current sources, or one voltage source and one current source can also be considered as two sources. In that case, to find out the response of any element, what is the response of meaning of response of any element? Response of any element means either current flowing through the particular element means resistor, inductor or capacitor in any electrical circuit. So if the current flowing through the element or voltage drop across the element or power dissipated by the element is called as the response of that element. So response of the any element is equal to the response of caused by individual sources. That means if there are two sources, first of all we'll calculate the response due to the one source only. At that time, other source will be replaced by its internal resistance. What is the meaning of internal resistance? If voltage source is there, it will be replaced by short circuit, and if current source is there, it will be replaced by open circuit. So whenever we are going to find out the response of one source, at that time other source, if it is voltage source, it will be replaced by short circuit, and if it is current source, it will be replaced by open circuit. So similarly, we will find out the response of each element, and then total response of both the sources is nothing but response in algebraic sum of responses by each individual source. So what are the limitation of this theorem? So it is not applicable for non-linear system. It is not applicable for the unilateral system because there is need of two or more than two sources. It cannot be applied whenever there is only one source is present. That means to apply the superposition theorem, minimum two sources must be present. Now, what are the steps? So consider the single energy sources at a time. Replace all energy sources by its internal resistance. Find out the corresponding response through a given element, and repeat above procedure for all energy sources to find the remaining individual response. Add all individual responses individually considering the directions to find the net response through a given element. So how many steps are there in case of the superposition theorem? For example, if there are two sources, so in step 1 we'll find out the response due to the one source. In step 2 we'll find out the response due to another source, and in step 3, as per the superposition theorem, we take the algebraic sum to find out the response because of the both the sources. So whenever there are n number of sources, number of steps while solving with the help of the superposition theorem is n plus 1 number of sources. That is, if 4 sources are there, number of steps will be 5. Now we'll try to understand the same theorem with the help of the one simple example, and then we'll discuss about the demonstration with the help of the virtual laboratory. So here we'll consider this example of the simple source in which there are two sources are present. That means one is 30-volt source, DC source, and second one is 8 ampere current source. As the condition for superposition theorem, there should be minimum two sources. So in this case, there are two sources. That means condition is fulfilled. We can apply the superposition theorem. Here question is find the current flowing through this 5 ohm resistance by superposition theorem. So what we'll do, we have to calculate the current flowing through the 5 ohm when both the sources are present. So as per the superposition theorem, since there are two sources are there, 2 plus 1, that is 3 number of steps will be there. So in step 1, we'll find out the response only when 30-volt source is present. At that time, another source will be replaced by its internal resistance. That is, since it is current source, it will be replaced by open circuit. And we'll find out the current flowing through the 5 ohm. It will be represented by I suffix 5 ohm dash. Now in step 2, we'll find out the current flowing through this 5 ohm resistance only because of 8 ampere source. At that time 30-volt source will be replaced by its internal resistance. That means it will be replaced by short circuit. And at that time we will find out the current flowing through the 5 ohm, which will be denoted by I suffix 5 ohm double dash. And in step 3, as per the superposition theorem, current flowing through the 5 ohm is equal to algebraic sum of responses due to the individual sources. That means I suffix 5 ohm is equal to I 5 ohm dash plus I 5 ohm double dash, and we'll get the current flowing through the because of the both the sources by superposition theorem. So we'll first of all we'll go for the step 1, that is when 30-volt source will be present and 8 ampere source will be replaced by open circuit, and we'll find out the current flowing through the 5 ohm. So I have redrawn this circuit here. 30-volt source is present. This current source 8 amperes current source is replaced by open circuit. We have to find out the current flowing through the 5 ohm. So what we'll do, when in this case always try to solve the circuit from opposite side of the source. So यहाँ पे source 30 volt है, that means we have to solve from the opposite side. So this is open circuited. Now since this is open circuited, current will not flow through it. So 5 ohm and 3 ohm are in series. So equivalent of this 8 ohm will be in parallel with 4 ohm. So 8 ohm parallel with 4 ohm, it will be in series with 10 ohm. So what is the current supplied by the source? I is equal to 30 upon 8 parallel to 4 plus 10, that is 2.37 ampere. So this is the current supplied by the source in this case. But actually we have to calculate the current flowing through the 5 ohm. So what we'll do, we'll use the current divider rule. So as in previous videos also, I have already discussed about the current divider rule and voltage divider rule. So what is the current divider rule? I have added the separate video also. So those who are not aware about the current divider rule or voltage divider rule, they can go through that video. So here we have to find out the current flowing through the 5 ohm. But in this case 5 plus 3, 8 ohm resistance is there. Here is 4 ohm resistance. So this current get divided into 8 ohm and 4 ohm. So by current divider rule, current flowing through the 5 ohm, that is I suffix 5 ohm dash, is equal to 2.37, that is current which get divided into opposite resistance through which we find out the current. So we have to find out the current through the 5 ohm. So opposite resistance is 4 ohm. So into 4 upon sum of resistances in which current get divided, that is 4 plus 8. So we'll get the 0.789 ampere from left to right. Why we are showing this current with its direction? Because at last we have to take the algebraic sum of the current. Now in step 2, we'll find out the response due to the 8 ampere current source. So in this case, this first source 30-volt source will be replaced by short circuit. So we have redrawn the circuit here. Again we have to find out the current flowing through the 5 ohm. So what we'll do, we'll solve the circuit from opposite side of the source. So this 10 ohm and 4 ohm are in parallel. that is equivalent resistance is 2.8 ohm, which will be in series with 5 ohm, and hence here we'll get the equivalent current up to this, equivalent resistance up to this is 7.8 ohm. Now this 7.8 ohm resistance is in parallel with 3 ohm resistance. So 7.8 ohm and 3 ohm are in parallel, and it will be supplied by this 8 ampere current source. So now we have to find out current flowing through the 5 ohm. That means we can say that we have to find out the current flowing through this 7.8 ohm resistance. So again we'll use the current divider rule. So current through the 5 ohm resistance is equal to total current which get divided, that is 8 ampere, into opposite resistance through which we have to find out the current. Since we have to find out the current through the 7.8 ohm, opposite resistance will be 3. So 8 into 3 upon resistances in which this current get divided, that is 3 plus 7.8, that is 2.210 ampere, but this current will flow from right to left. Now, as per the superposition theorem, current flowing through the 5 ohm is equal to I5 ohm dash plus I5 ohm double dash, that is algebraic sum of responses caused by individual sources. So it will be 0.789 from left to right plus 2.210 from right to left. So algebraic sum will be difference of this 1.422 ampere, and final direction of current is for the direction of predominant current, that is 2.210. So we can say that when both the sources are present at that time, as per the superposition theorem, current of 1.422 ampere will flow through the 5 ohm resistance from right to left direction. So I hope this example is uh, uh, help will help to understand the superposition theorem. If you are interested more in detail of the superposition theorem, I have separately added the video based on superposition theorem on my channel Vidyut Yog. Now, actually, we have to study about the verification of the superposition theorem with the help of the VLab. So, for that purpose, what you can do, just go on the Google and search VLab, that is virtual laboratory. So when we'll search about the VLab, you will get the official website of virtual laboratory, that is www.vlab.co.in. Just click on it, then you will get the broad areas of virtual labs, in which go to the electrical engineering lab. Then here you will get the first lab, that is analog signal network and measurement lab. When you will click on this, you will get this window. Just click on the list of experiment, and in this list at the 4 number there is theorem, verification of superposition theorem. So once we click on this experiment will get open. So what is the aim of the experiment? To verify the superposition theorem. Regarding the theory, we have already covered the theory in this video, that is what is the superposition theorem. But again we'll try to understand, if a number of voltage or current sources are acting simultaneously in a linear network, the resultant current in any branch is the algebraic sum of that current that would be produced in it when each source acts alone, replacing all other independent sources by their internal resistances. So for example, suppose this is the one circuit in which there are resistances R1, R2 and R3, and there are two sources V1 and V2. That means condition for superposition theorem is verified. So suppose I have to calculate the current through the each resistance. What we'll do? First of all, we'll consider only one V1 source and we'll replace other voltage source by short circuit, and we'll find out the current through each resistance. Then in step 2, we'll consider only V2 source. V1 will be short circuited, and we'll find out the current through the R1, R2 and R3. Then algebraic sum of each current flowing through the each resistance because of each source will be equal to the equivalent current flowing through that resistances. So they have given some multiple choice questions for the pre-test to understand your knowledge about the superposition theorem. You can read those questions regarding the procedure. Now, since this network is needed to understand for the superposition theorem, for the simulation of superposition theorem, we'll just try to understand. This is the one source. Sorry, this is the circuit diagram of experimental setup for verification of superposition theorem. In this circuit diagram, there are two sources. One is of 220 volt source and second one is of 120 volt source. Both sources are DC supply. Now they have made the arrangement of bidirectional switch so that on one side you can connect this side to the source, or other side you can short circuit this path with the help of this switch. So for that purpose, double pole double throw, that is DP/DT switch is used. Same arrangement is done for the another source of 120 volt DC source. On one side of DP/DT switch, you can connect this 110 volt source to the circuit diagram, whereas on another side you can short circuit this path. And in the circuit there are three resistances. There is one resistance of 85 ohm, second one of 50 ohm, and third one of 185 ohm are connected. And for measurement of current through each resistance, separate meters like A1, A2 and A3 ammeters are connected. Okay, now what is the procedure? Suppose I have to find out the current flowing through this 85 ohm, 50 ohm and 185 ohm by using superposition theorem. Step 1 will be only source S1 or only source 220 volt DC source will be present. At that time, another source will be replaced by its internal resistance. That means 110 volt will be short circuited. In step 2, when 110 volt only source is present, at that time another source, that is 220 volt, it will be replaced by short circuit. And whatever the current you will get due to the response of individual source, algebraic sum of this will be current flowing through these resistances when both the sources will be present. So without wasting time, we will go for the simulation. So in this case, same circuit diagram is present, which we have already discussed. So here are 220 volt supplies there, and here 110 DC supply source is present. Three resistances of, here we can change the resistance value. Right now we have set that value to the 200 ohm, to 300 ohm and 500 ohm. You can change this value by using this up and down arrows. Now what we'll do, we'll try to find out the current flowing through this 200 ohm, 300 ohm and 500 ohm resistance by using the superposition theorem. So for that purpose, for the DP/DT switch, if you click on this DP/DT switch, you are having two options. One, power, and second one, short. When we'll select the power, that means 220 volt DC source is connected to this, is supplied to this connection diagram. When we connect the short, select the short, that means this path is short circuited. So for the step 1 of this, as there are two sources, of course number of steps will be 3 to find out the current by using the superposition theorem. So what we'll do in step 1, we'll connect the power to this source 1. So 220 volt supply will be connected to this circuit diagram. And at that time, other source, that is voltage source, will be replaced by short circuit, and for that purpose we'll select short on another side. Okay, so I repeat, in step 1 we have connected 220 volt DC supply source and other source is short circuited. Now we'll simulate it to find out the current. So when we click on the simulate button, actually for the simulation purpose they have given the stepwise procedure here. They have considered the case 1 as both the sources are present, case 2 only one source is present, case 3 only second source is present. So what we'll do, in first case both the sources will be on power mode, that means both the sources are present. At that time we'll find out the current. So now the current is present, that is current through the A1 is 0.3903 2 ampere, current through the A2 is minus 0.10645, and in A3 ammeter current is 0.28387. where A1 represent the current flowing through the 200 ohm resistance, A2 represent the current flowing through the 300 ohm resistance, and A3 represent the current flowing through this 500 ohm resistance. So this is the current when both the sources are present. Now for the superposition theorem, what we'll do, we'll consider the case 2 in which 220-volt source is present whereas other source is short circuited, and at that time we'll find out the current. We'll press on the simulate button, so it will give the current. So current is current in A1, A2 and A3 are 0.456774 minus 0.35484 and 0.21290. Now the for case 3, so what we'll do, this second source, it will be present, so we'll select it to the power mode, and first source will be short circuited and we'll simulate it. So you will get the current, that is current flowing through the A1 is minus 0.17742, current through the A2 is 0.24839, and current flowing through the A3 is 0.07968. So now what we'll do, we'll fill this data to the table, and now all the three cases readings are here, and from this it is clear that now suppose we have to calculate the branch current I1. So it is the algebraic sum of responsive to the one source, that is V1 0.56774 ampere, and responsive to the another only when another source is present, that is minus 0.17742. So if we consider the addition of this I1 and this I1, it will be equivalent current when both the sources are present. Same